Hello everyone, welcome back to my channel. This is the place where you learn new skill every time you visit. So keep updating yourself by subscribing to the channel.
This video is third in the problem solving series, and today we would be discussing here summing and printing fractional and exponential series in Java. Series which we would be doing today is this fractional and exponential series 1. And here if you look at the series, the first thing which we need to look at the series is how many variables it has, because the variable values are to be taken by the user. From the user. So here we have x and n. So these are the two values which we will take from user, and s is also variable, but that will be calculated and printed as an answer. So now we observe in the numerator, in case of fractional series, we of course have to observe the numerator and denominators separately. So here if we observe the numerator has some exponential series going on where the base is same x, but the power keeps on changing. So, and if you observe here, there's no symmetric or uniform increment in the power. So whenever you don't have a uniform increment in the power or decrement in the power, what you need to do, you just always think of natural series, sum of the square of the natural series and cube of the natural series. So if I observe this is 1, which is square of 1. This is 4, square of 2. 9 is square of 3, and 16 square of 4. So that means the power of the numerator is square of the natural number. Now if you look at the denominator, it is 2, which becomes 4, which becomes 8, which becomes 16. So it is getting multiplied by 2. So it is getting doubled or twice. Alright. So now once we have collected this logic, we'll code it. Alright. So just to code all these, we'll quickly move on to the BlueJ, and there we'll be coding it. So I'll just switch on to the BlueJ here. I'll keep the BlueJ on the same screen so that I can have a look at the series also, and I can code it simultaneously. So over here, I have created a class called series. Let's make it series 1 because this is the first series. I have taken a scanner class to take the input. The variables are x for the value of x, n for number of terms, p for the power, and f for the factorial, because we know the denominator shows us the factorial. Now since this sign I don't need right now because all terms are positive, same sign. Sum equals to 0 double because we need the sum, of course. Then denominator and numerator are the part of the fractional series fraction. So now I have taken the number of terms from the user into n and the value of x from the user. After that, as I told you, the first thing which we would observe is initializing the numerator and the denominator, right? So to initialize the numerator, I'll see that numerator is actually x to the power something, or x to the power square of the natural number, as we just discussed. Whenever you think of a natural number, square and cube of a natural number series, always think of the natural number series, right? Like 1, 2, 3, 4. So the first term is going to be 1, right? So what I'll do, I'll put power equals to 1, and then my denominator is visible over here is 2. Okay, so then I run my loop in I, which goes from 1 and it goes till n increases by 1. Now here inside I will calculate the numerator and then solve it. So my numerator is going to be here. Before calculating numerator, I do have a factorial of denominator here. So just before doing any other process, once you enter the I loop, you just have to calculate factorial. Now what is a factorial? Factorial is a product of numbers till that number. For example, if I have to find factorial of 5, it is 1 into 2 into 3 into 4 into 5. So from 1 till that number, you have to multiply all the number. So whenever the factorial comes in a series, just introduce this series, this loop or this set of codes, few lines of code, which is the factorial code. So f will be 1 because I'm calculating factorial in f. The one loop will go from 1 till the number whose factorial you are calculating. Here we are calculating factorial of a denominator whose initial value is 2, which I have initialized here. So this will go till denominator and j plus plus. Now what does the factorial series do? The factorial series is going to multiply every value of j into f. Alright. So now at this point where my cursor is, I have found out the factorial of denominator. Now I have to set a numerator. So numerator equals to, as you can see, that it's math.power x comma p. Okay, now it's not actually p, it is square of the p, because as I told you, the power is square of the natural number, and I'm starting the first value of p as 1, so square of the natural number, so square of p. Okay, now I need to print the series. So what I'll do, I'll say system dot out dot print a little gap. I'll print numerator plus the slash sign, division sign, and then the factorial of f, value of f, because the denominator is factorial of the values which are changing, so which is f over here. Now I need to do the increment. Now increment of my power is 149, but as I told you, whenever you are dealing with square and cube of the natural number, you think of the natural number series. So the first term of natural number was 1, that's why we put 1 here, and the increment of the natural number is by 1, so I will increase p by 1 only. All right, so it becomes 2, and next time when it comes over here, 2 into 2 4. After that it will become 3, and next time when it comes here, 3 into 3 9. So this is the way we handle the square and the cube series. Now what about the denominator? The denominator is getting twice. Okay, so denominator is previous denominator multiplied by 2, and of course we have to do sum here also. So here I'll do sum equals to sum plus numerator upon factorial of denominator, which is f. So here it closes the while loop, and then I print the answer, the sum of the series. Print sum of series is plus s. Okay, I think that works. Yeah, both main function and class close here. Let me run and see it how it works. So when I compile it, it says no syntax error over there. So I'll go to the main screen and try to run it. Now I'll give the value of x as 1 and number of term as 1, so that I get only the first fraction, and my first fraction with x value 1 to the power 1 will be 1, and factorial 2 is 2, so I should get answer as 0.5. 1 upon 2 is 0.5 for which value? For the value x1 and n1. Let me check that. So I'll just go to the screen over here and I'll run this series. Okay, so here I'll just scroll it down and I'll give the values of x as enter the number of terms 1 and x as 1, so it gave 0.5. That's perfectly all right. It also shows 1 upon 2 the series term. All right, I'll run it again once with values of x equals to 2 and n equals to 2, so that I will get these two terms in the series. And when I say x equals to 2, so 2 to the power 1 will be 2, and 2 upon 2 will be 1. So the first fraction solved as 1. Now if I go to second fraction, 2 to the power 4 will be 2, 4, 8, 16, I believe. 16, and factorial 4 is 24. So 16 upon 24, and that will be added to 1. Okay, let's see how it works. So I'll go to the main screen again and run it. Here the object is ready. Number of terms 2 and x is also 2. Yep, it gives me 16 upon 24, you can see, and the sum is also correct. So this is the way we solve a series. Okay, this series which has all numbers positive. Now there can be cases when you have all number with different terms. Okay, plus minus alternate terms, or first is plus and then the series starts from plus 2 plus and then minus plus minus alternate. So let's see the next series, next question of which we have to handle in this video. Let's see what is that series. So this is the second series of this video, and here we observe that the slight change. Now the signs are alternate, but the first term does not fall into the sequence of alternate sign. So what we can say that this series is actually starting from here. All right. So the first term is not within the series. So what we'll do, we'll calculate this separately and print it out and store it into S beforehand, before the loop. And then we are going to do the process. Now let's understand what is this logic in the power and the denominator of the series. If you observe here, this is 7, 26, 63. As I told you that if you don't find a direct logic or direct uniform increment or decrement, just go for the square of the natural number, cube of the natural number. If I go for square of the natural number, which will be 1, 4, 9, which is nowhere near. But if I go for cube and cube of the natural number, I should consider all the powers starting from this also. Cube of the natural number, which is 1 here, and then 2 cube is 8. Yeah, it is somewhat near. And 3 cube is 27. Yeah, and 4 cube is 64. So you can see that the powers are 1 less than the cube of the natural number. Okay, now let's look at the denominator. The denominator again, 2, 5, 10, 17. We are not finding a uniform uh, increment or decrement in that particular denominator. So again, we look for the square and cube of the series, natural number series. So if we go for square of the natural number series, square of 1 is 1, square of 2 is 4, square of 3 is 9, and square of 4 is 16. So yeah, it looks nearer, and we can say that the denominator is square of the natural number plus 1. So power is cube of the natural number minus 1, and denominator is square of the natural number plus 1. Now we'll code this in BlueJ. We'll try to apply this logic in BlueJ. So let me pull out BlueJ here. Okay, so here is the BlueJ, and I have already defined a class. I will explain you how we are going to do this. So here the variables would be similar, x and p, f, and then one more variable sign will add on. Now since the first term of the series, okay, now as I told you, the series starting from here, first term of the series is plus, so I initialize the uh, sign. Initial value of sign is going to be plus, as mentioned here. Okay, and now we have double variable sum, denominator, numerator. We got number of term, we got x from user. Now, as I told you, when you're looking for a square and cube of the natural number series, your initial value is always going to be 1, and increment will also always going to be 1, because the natural number actually start from 1 and increases by 1. So for that reason, the first term power value is 1 and denominator is 1, because both are related to the square and cube of the natural number series. Now, as I told you that this term, the first term, which is out of the series with its plus sign, so I'm going to calculate this before the loop starts and then store it into the S. Okay, that's what I'm doing over here. So what is being done here is we are calculating S equals to math.power x cube of the natural number, or p, minus 1 upon 2, because I can see that the 2 factorial is 2. All right, and then I can print it out also, system.out.print, same way math.power dot this plus 2. Now this 2 shall come inside quotes, because we have fixed it. All right, and now once the first term is done, we'll increase the value of p by 1. Okay, and denominator also shall increase by 1 for the next term, so I'll increase the denominator also by 1. Okay, and now inside the loop, now since I have already printed the first term of this series, so I'll run this from 2. Okay, because the first term is printed. Now here, as I told you, whenever you have factorial, you have to introduce this loop, factorial loop. And now you will calculate the numerator, which is, as you can see in the series, which is x to the power p. So math.power x, and now power is cube of the natural number minus 1. And then you will calculate the sum, the numeric value of sum, which is the initial sum, where we have already summed the first term, plus the numerator which you just calculated divide by f. That means factorial you have already calculated here. Then you will print this combination of numo upon f. Your power will increase by 1 and denominator will increase by 1. Other than that, since you have to handle the plus and minus sign also, alright. So while calculating the numerator, because sign always go to the numerator, I'll just multiply this with sign multiply by this whole thing, sign multiply by this thing, okay, and this will calculate numerator and then it will get solved over here. So now when this initial sign was plus, how to make it negative now? So where here where the increments are coming, I'll say sign equals to sign into minus 1. So when plus 1 multiplies by with minus 1, it becomes minus 1, and for the third term, when minus 1 multiplies by minus 1, it becomes plus. So this is the statement which takes care of the alternate sign, and then we're printing the sum. Okay, let's run it. It compiles with no error, so I'll go to the main screen and try to run the series code. Here it goes. So I'm running void main. Right, I'll just scroll this side. Yeah, so number of term, if I give 1 and x also 1, so it prints the 1 upon 2. Yeah, x to the power 0 is 1 and 2 is already factorial 2 is 2, so it prints out 0.5. Okay, now I'll do it for the two terms. So I'll go back to the same object and run it. So number of terms 2 and value of x is 2, so it gives something like that. This, let's check it whether it's correct or not. So it is x to the power 2 will x2, and 2 to the power 0 is of course 1, and factorial 2 is 2. So this is fine, the first term. Next term is 2 to the power 7. So 2 to the power 7, 2, 4, 8, 16, 32, 64. Yeah, it's going to be 128, and factorial 5 is 120. Then when we add this, becomes this. Okay. So this is the way we solve all fractional, exponential, and factorial and series. And I hope you understood this well. Even if you have still any doubt, you can comment me. I'll get back to you. Thank you for giving me your time. Take care. Bye bye.
If you are new to the channel, please subscribe it. Also press the bell notification so that you get notification as soon as I release a new video. Share and like the video.